All right, so we're going to start chapter 12. And so chapter 12 is on sequences and series and that kind of thing. So a sequence is just a function. You can think of it like a function. Um, the domain is the set of natural numbers, and the terms of the sequence are the function values. Another way to think of it, this is just kind of a pattern of numbers that uh, you can follow in it, to infinity. Um, and so we use subscripts for the different terms. So a subscript 1 would be the first term, a subscript 2 would be the second term, and so on. And then a subscript n would be the nth term, just generally speaking, the general term. So this first example, find the first 5 terms and the 100th term. So when we have this, so this is the formula rule. So you can think of this as like an f of x. F of x equals 2x minus 1. And if you want to find f of 1, f of 2, f of 3, so on, you would know how to do that, or f of 100 even. So this is just the same thing. So if we want to find a sub 1, we're just going to plug 1 in for the n. So 2 minus 1, that would be 1. A sub 2, 2 times 2 minus 1, that would give us 3. A sub 3 would be 2 times 3 minus 1, which would be 5. Now notice these are going up by 2. Another thing to notice, this looks like a linear function. So if this was f of x equals 2x minus 1, we would recognize that as a linear function. And so this is kind of a linear sequence. It's called an arithmetic sequence, which we'll talk about in 12.2. But the same idea applies in that the slope of this would be 2. And these are going up by 2, just like the slope would be, the y values would be going up by 2 if this was a linear function or a linear graph. So once you kind of notice that, you don't really have to do the calculating here. Not that this is complicated, but it can get a little bit more complicated. But we're just going up by 2. So A4 would be 7, A5 would be 9, and then A100, of course, you just need to plug that in. So 2 times 100 minus 1, and that would be 199. So that's the basic idea. So we're just plugging in numbers for n at this point. The next one, we have n squared minus 1. So we're going to do the same thing. A sub 1, or C sub 1, I should say, would be 1 squared minus 1. This one, of course, is not going to be linear. C2 would be 2 squared minus 1, which would be 3. C sub 3 would be 3 squared minus 1, which would be 8. C sub 4, 4 squared minus 1, which would be 15. C sub 5 would be 5 squared minus 1, which would be 24. And then C sub 100 would be 100 squared minus 1, which would be 9,999. And then the next one, we have n over n plus 1. Oops. So T sub 1 would be 1 over 1 plus 1, which is 1/2. And this one, you will see a pattern. So 2 over 2 plus 1, which would be 2/3. T sub 3 would end up being 3/4. T sub 4 would end up being 4/5. T sub 5, 5/6. And then T sub 100 would be 100 over 101. All right. So basic examples there. We can, of course, do a lot more with this. Find the nth term whose first several sequences are given. So this is really just looking for a pattern and kind of getting a formula for what we have here. So the A1 would be 1/2, A2 3/4, A3 would be 5/6, A over 4 would be 7/8. So one thing, this is just basically pattern recognition. I can't really give you a formula for doing any of these. This is just, you recognize a pattern, you come up with a formula for the next term and see if it works. I mean, we could expect the next term would be 9 over 10, and then we'd have 11 over 12, and so on. So one thing I noticed, the subscript is half of the denominator each time. So the a sub 1 is 2, a sub 2 is 4, a sub 3 is 6, and so on. So I would suggest that the numerator of a sub n would be 2 times n. And then the next thing to notice is that the numerator is 1 less than the denominator, so we just need to put 2n minus 1. And that would be fine. We could also write this as 1 minus 1 over 2n, which is just rewriting this fraction. So either way is fine. But that's really all we're doing. If we're finding the nth term, for now, we just need to kind of figure out what the pattern is. So this next one, -2, 4, -8, 16, -32, we notice that every other term is negative. So that will tell us probably that we'll have a -1 to the n. This is typically what you do if the sign's alternating. If the first number is positive and the second number is negative, then you'd make it -n or -1 to the n plus 1. So here we have -1 to the first, would give us a negative first term. -1 squared would give us a positive second term, and so on. And then the rest of these are powers of 2. So we could write this as 2 to the first, 2 squared, 2 to the third, so on. So that'd be 2 to the n. Now, in this case, we can combine these and just write it as -2 to the n. So your initial idea can be refined. In other words, you don't have to come up with the final formula at the beginning. You can kind of notice patterns and just kind of put the pieces together, and then you can simplify once you kind of get all the pieces. But this would probably be what you would want to write, although technically this is correct as well. Okay, so I think that's enough for this one. We'll pick it up in the next one.